Right, let's review this last section of chapter 1, which is comparing linear velocity to angular velocity. So this was one of the problems that we had in class. We have a DVD, it's spinning at 200 rotation per minute when the laser is reading the outside track. The inner track is 2 centimeters from the center, the outer track is 5.25 centimeters from the center. And the DVD is going to speed up or slow down depending on which track it's on. So let's talk about that. I have been using a simpler example here. So let's say we have a circumference of 16 centimeters on the outside, and let's suppose that we have a circumference of 4 centimeters on the inside. Well, if we are reading 16 centimeters per minute, let's say, then that would be one rotation on the outside in 1 minute, because that's how long it would take to read 16 centimeters of data, let's say, in 1 minute. Okay. Now, if we want that to be the same linear velocity, so we still want to have 16 centimeters of data, but now we want it, and we still want it in 1 minute, but now we're on the inner track. Okay, well, in order to do 16 centimeters worth, that's going to be 1, 2, 3, 4 rotations. So in order to complete 4 rotations in 1 minute, it would take 15 seconds per rotation. So this problem is kind of confusing because it keeps saying, like, how fast is it spinning? When they're saying how fast, they're talking about angular velocity, not linear velocity. So for the linear velocity to stay the same, the disk is going to have to speed up as the laser is going towards the center in order to still read the same amount of information in the same amount of time. So it is going to have to speed up, because to cover 16 centimeters, we would have to spin around 4 times, right? But on the outside, we only have to spin once to get 16 centimeters. So that was just like a really basic example. In this particular problem, we have different values. So what is the linear velocity when laser reads the outside track? Okay, so the outer track has a radius of 5.25 centimeters. Okay, so that means I'm just going to kind of write this out and then I'll show you my unit conversion. That means one rotation is equal to 2 times 5.25 times pi, the circumference, right? One rotation is equal to the circumference. And we are rotating at 200 rotations per minute. So I have 10.5 pi centimeters is equal to one rotation. So I'm going to set this up as a ratio. 10.5 pi centimeters per rotation. And it is spinning 200 rotations in 1 minute. And you can see why I'm going to multiply these. So I'm multiplying the rate by the distance, and that's going to give me, look at my units of measure here, rotation, that gives me my centimeters per minute. So what I'm doing is I'm converting a rotations per minute into a linear velocity. I'm converting an angular velocity into a linear velocity. Okay, so I'm going to be doing like a lot of multiplication with these types of problems, because I can quickly see should I multiply by 200 over 1 or 1 over 200? And the way I figure out how much to multiply by is I want my units to cancel. So here my rotations cancel, and then I end up with a centimeters per minute result, which is a linear velocity. So linear velocity is distance over time. Angular velocity is going to be like rotations per minute. Okay, so then I can just multiply 10.5 pi times 200, and I should really have a calculator ready so that I'm not fumbling while I'm making this video. 10.5 times 200 is 2100 pi centimeters per minute. Okay, so that's the linear velocity. Okay, now that's because of the outer track. Now we're saying, okay, we need the DVD to spin at the inner track at this velocity. So we're going to start at 2100 pi centimeters per minute. And we need to figure out how to get the number of rotations per minute. So now we're kind of going back to RPMs. And again, I know that's why it's confusing, because like how fast, same velocity, why isn't it the same answer? What they're saying is how many rotations per minute does the DVD need to spin on the inner track so that it's completing the same amount of data as the outer track. So I start with my current linear velocity, and then I'm going to go back to angular velocity. So the inner track is 2 centimeters per second. And what that means is that one rotation is equal to, so this is a radius, so that would be 4 pi centimeters. One rotation is equal to the circumference. Okay. And again, the reason that I'm multiplying by one rotation over the circumference instead of circumference per rotation, because I want my centimeters to cancel. And then my units are rotations per minute. Okay. And then another question I get is like, well, why am I multiplying at all? Well, remember how I started with like one rotation is equal to the circumference? Because that's true. One rotation is the distance around. Well, the distance around is the circumference, right? Well, if these two things are equal, I'm basically just multiplying by one, right? If I'm multiplying by two things that are, if I'm multiplying by a ratio where the numerator is equal to the denominator, I am multiplying by one. You can multiply by one whenever you want. That's basically what unit conversion is. It's the idea of multiplying by ratios equal to one. So I am multiplying by one because one rotation is equal to 4 pi centimeters. Then my centimeters cancel, and I end up with, my pi's cancel, 2100 divided by 4 is 525 rotations per minute. Okay. Now, in this next problem, we kind of have the opposite thing happening, where the rotations per minute is not changing. The linear velocity is changing. So in this problem, we're talking about the car. You can read through the problem yourself. You should have already done this. A car thinks, or this particular car thinks, that if it revolves the axle 902 times, that means the car has traveled 1 mile. So the center part of your wheel, if it spins around 902 times, then they're saying, okay, well, the wheel or the wheels of your car after 902 times will have completed 1 mile. So Linda is super smart, and she decides to not do what the car manufacturer says, and she buys her own weird tires. Okay. So we want to figure out, is she traveling more than a mile when her car thinks it's a mile? Or is she traveling less than a mile when her car thinks it's a mile? So again, the car is saying it's gone 9. The car, like the speedometer, the odometer, both of them are saying, I felt the axle go 902 revolutions. That's been a mile. But when you change the tire size, it actually is not the mile that your car thinks it's traveled. So how do we figure this out? So she's got 26-inch diameter tires. So that's 26 pi inches is equal to 1 rotation. 26 pi inches is 1 rotation. And she is traveling at 902 rotations. Okay. So let's figure out how far this actually is. So it's going to be 26 pi inches times 902 rotations. And that gives me the number of inches she has traveled, which is not super helpful because we don't really use inches when we're talking about cars. We probably want to have miles. So let's go ahead and convert this to miles. So again, unit conversion, you're basically multiplying by things equal to 1. So I have inches in my numerator, so I want to be dividing by inches. So 1 foot divided by 12 inches. My inches cancel. Now I'm in feet. That's a little better, but let's go ahead and get into miles. Let's multiply by 1 mile is 5,280 feet. So 1 mile is 5,280 feet. That's just a unit conversion you just want to have memorized. Okay, so now when I look at my units, now I end up with the number of miles that I have traveled. Now if I multiply this out, I am going to get the number of miles that she travels in 902 rotations. So that's going to be 26 times 902 divided by 12 divided by 5280 multiplied by pi. And I get 1.163. So remember in my class, you have to round everything to 3 decimal places. So I get 1.163 miles. So again, 902 rotations with this tire size is 1.163 miles. The car thinks I've only traveled 1 mile, but I've actually traveled more miles. So my odometer is going to be off. My odometer is the one that tells me like the total amount of miles that I've traveled. So again, I'm actually going further. Now her speedometer, which again thinks that she is traveling at a different speed and a different distance than she actually is. So her speedometer says 40 miles per hour, but she's not actually multiplying, or she's not actually traveling at 40 miles per hour. How fast is she traveling? Okay, so you can pretty much do a basic ratio here, or you can do like the unit conversion idea. If you're going, so 1 mile, that's what her car thinks, is to 1.163 miles. That's how far she's actually traveled, is equal to the 40 miles per hour her car thinks that she's gone versus her actual miles per hour. Okay, so this ratio does hold true. So again, I kind of did like what the car thinks and what is actually occurring is equal to what the car thinks versus what's actually occurring. Okay, so if you wanted to solve, you could cross multiply and you get x equals 40 times 1.163. And you would end up with 40 times 1.163, 46.52. I should actually have a more exact answer than that, but I'm using my phone as a calculator, which is a horrible idea because I'm not getting third decimal place accuracy. So I apologize about that. I should actually have one extra decimal here. But you can see that she is actually moving faster than her car thinks that she's moving. The last way that you could have solved this problem instead of setting up a ratio, which clearly is the easiest way in this particular case, but the other way you could have done it is you could have said, okay, well, 902 revolutions is supposed to be a mile, right? So 902 revolutions. Now, if you're traveling at 40 miles per hour, then what we can do is say, okay, well, how many revolutions per, 902 revolutions is 1 mile. That's what your car thinks, right? So let's figure out how many revolutions per hour your car is going to make. So your car is going to make 40 times 902 revolutions. That's 36,080 revolutions per hour. Okay, well, what is 1 revolution in actuality? 1 revolution is 26 pi inches. And then that gives me inches per hour, which again is not super useful. So that's feet, 12 inches. Inches cancel. And then there are 5,280 feet in 1 mile. So what I could do is figure out the total number of revolutions and then do a unit conversion to get miles per hour. And I could do it this way. And so I multiply by 26 times 3.14159,265 divided by 12 divided by 5,280. And I get 46.513. And that is the number of miles per hour that, so I can actually see I'm a little bit off here in my previous answer. But that is how fast my car is or Linda's car is actually traveling at, even though her car thinks that she's traveling at 40 miles per hour. Because you can figure out, again, the total number of revolutions. And then based off of what one revolution actually is, you can do some unit conversions to get miles per hour.